The first inconsistency appeared during a routine calibration check inside a privately owned clock repair shop, where all timekeeping devices had been scheduled for synchronized verification against a certified atomic reference. The shop itself was small, positioned along a commercial street with steady pedestrian flow, and contained over 200 mechanical and quartz timepieces distributed across walls, display cases, and workbenches. During the verification process, each device was expected to align within standard tolerance after adjustment. None of them did. Instead, every clock and watch in the shop displayed a different time. The divergence was not random drift. Each device held a stable, internally consistent time reading, but no two matched. More significantly, none corresponded to the external reference signal being broadcast into the shop during calibration. The atomic synchronization signal remained stable. The devices simply did not respond to it. Initial inspection focused on interference. The possibility of localized electromagnetic disruption was considered, given the density of devices and wiring in a confined space. However, the behavior extended equally across mechanical watches with no electronic components. Spring-driven systems, pendulum clocks, battery-powered quartz units, and digital displays all exhibited the same condition: stable operation, independent timekeeping, and complete resistance to external synchronization. A second calibration attempt was performed using manual adjustment. Each device was physically reset to match the reference time. For a brief interval, alignment appeared successful. The hands were positioned correctly, digital displays updated, and all devices showed identical time within visible tolerance. Within minutes, divergence resumed. The separation did not occur gradually. Observers noted that individual devices would maintain correct alignment for a short duration before abruptly shifting forward or backward by measurable intervals. These shifts did not follow mechanical constraints. A pendulum clock could advance several minutes without any corresponding increase in oscillation frequency. A quartz watch could lag by seconds despite stable voltage and crystal behavior. Each device behaved as though it occupied its own temporal reference frame. The shop owner initially attributed the issue to environmental factors and requested external verification. Portable reference clocks were brought into the environment. Upon entry, these external devices maintained correct synchronization for a short period before exhibiting the same divergence pattern. Once removed from the shop, their timekeeping returned to normal operation without residual error. This containment suggested a localized condition. Further observation revealed a more structured pattern. The divergence between devices was not static. Instead, each clock maintained a consistent offset relative to others, but these offsets slowly evolved over time. Certain clocks appeared to approach alignment with one another, only to diverge again before synchronization could occur. The relationships between time readings formed shifting clusters, as though multiple timelines were briefly converging and separating within the same physical space. At this stage, a temporary stabilization was reported. For approximately 40 minutes, all devices within the shop ceased shifting. Each clock maintained its current offset without further change. The environment appeared stable, and no new divergence events were observed. This led to a preliminary assumption that the anomaly had reached equilibrium. That assumption did not hold. When the next verification cycle was initiated, the devices did not resume divergence from their stabilized states. Instead, each clock shifted again, but this time, the magnitude of displacement increased significantly. Offsets that had previously been measured in seconds or minutes expanded into hours. One wall-mounted clock advanced nearly 3 hours within a single observed interval, while a wristwatch in a display case moved backward by over an hour without any mechanical reversal of its movement system. The inconsistency extended beyond the devices themselves. Customers entering the shop began reporting discrepancies between their personal devices and the clocks on display. A mobile phone checked against a wall clock would show a difference of several minutes. When rechecked moments later, the discrepancy had changed. However, once outside the shop, the phone's time aligned again with network synchronization, suggesting that the effect did not persist beyond the immediate environment. This marked the first confirmed intersection with general human activity. At this point, a decision was made to isolate the environment. External synchronization signals were disabled and all incoming devices were removed. The shop was left with only its original inventory. The expectation was that removing external variables would reduce the observed complexity. Instead, the divergence accelerated. The clocks no longer shifted individually at irregular intervals. Groups of devices began changing simultaneously, forming temporary synchronization clusters that lasted only seconds before breaking apart. A set of watches on a central table would align perfectly with one another, then abruptly scatter into new offsets. Wall clocks on opposite sides of the room would momentarily match before diverging in opposite directions. The behavior suggested an underlying structure, but no consistent rule could be derived. A mechanical chronometer placed at the center of the room exhibited a distinct pattern. Unlike other devices, it did not continuously diverge. Instead, it remained fixed at a single time value for extended periods. However, each time the surrounding devices shifted significantly, the chronometer would adjust by a corresponding amount, maintaining a position that appeared to follow the overall distribution of offsets without matching any specific device. It did not lead the changes. It did not lag behind them. It repositioned itself within them. Attempts to remove the chronometer from the shop produced an unexpected result. While being carried toward the exit, its time display remained unchanged. However, upon crossing the threshold, the device immediately synchronized with external time, while the devices remaining inside continued their independent divergence. When returned to its original position, the chronometer resumed its prior behavior, adopting a new offset consistent with the internal environment. This indicated that the anomaly was not bound to individual devices, but to the space itself. As observation continued, a pattern emerged that could not be attributed to random variation. The distribution of time offsets within the shop began to reflect future states of the devices. Certain clocks would display times that other clocks would only reach later after subsequent divergence events. The relationship was not linear. A clock showing a future time relative to others would eventually be matched by those devices, but only after multiple shifts had occurred. The implication was not immediately accepted. A secondary analysis compared recorded offset distributions over successive observation intervals. When mapped sequentially, the configurations appeared to repeat, but with displacement. A cluster of synchronized devices observed at one point would reappear later in a different location within the shop, involving different physical clocks but maintaining the same relative offsets. The pattern was not tied to specific objects. It was tied to the arrangement of time itself within the space. By the end of this phase, the anomaly demonstrated independent existence. It did not depend on device type, external signals, or user interaction. It persisted within the defined boundaries of the shop and continued to produce measurable, repeatable temporal contradictions. And it had begun to exhibit alignment with states that had not yet occurred. The shift from isolated anomaly to operational concern occurred when the shop's internal time distribution began interacting with external scheduling systems. A municipal maintenance crew entered the building to inspect electrical wiring after irregular power consumption was reported along that section of the street. Their work depended on coordinated timing, circuit testing sequences, load cycling, and relay verification all required precise synchronization between handheld instruments and external grid references. Inside the shop, those instruments did not fail. They complied with the same condition already observed. Each unit maintained a stable reading, yet none aligned with the others or with the grid signal. More critically, the sequence timing used for load testing began producing inconsistent results. Circuits that should have activated in a defined order appeared to trigger out of sequence when observed through instruments inside the shop, while external monitoring indicated normal operation. The electrical system itself had not changed. Only its measured timing within the environment had. This marked the first instance where the anomaly interfered with a system whose reliability extended beyond the shop's interior. To prevent further disruption, the building was temporarily removed from synchronized grid diagnostics. However, a secondary effect emerged shortly afterward. Automated billing and usage tracking systems, which relied on time-stamped consumption data, began registering overlapping intervals originating from the shop's meter. Energy usage appeared to occur simultaneously across multiple, incompatible time windows. The data did not indicate increased consumption. It indicated conflicting temporal attribution of the same consumption. At this stage, a working assumption was proposed. The environment was not altering mechanical function, but redefining the temporal reference each system used to record its activity. That interpretation was supported by a controlled test involving a sealed digital recorder placed inside the shop. The device captured a continuous video feed with embedded timestamps. When reviewed outside the environment, the footage remained visually continuous. However, the timestamp overlay exhibited discontinuities, forward jumps, reversals, and repeated intervals. The recording itself had no missing frames. Only its temporal labeling had fractured. This distinction became central to subsequent analysis. Attention returned to the devices within the shop. The earlier observation that certain clocks displayed times corresponding to future states of others became more pronounced. Entire clusters of devices would briefly align to a configuration that matched a previously recorded arrangement but offset in sequence. These configurations were no longer isolated events. They formed a progression. The environment appeared to cycle through its own temporal states. Not in a repeating loop, but in a shifting sequence where each state anticipated or reflected another. A temporary dead end occurred during this phase. For several observation cycles, no new behavior emerged. The divergence continued, clusters formed and dissolved, but no additional systems were affected. This led to a provisional classification of the anomaly as locally contained, with no further escalation expected. That classification was revised when the shop's internal time distribution began correlating with external schedules that had not yet been executed. A delivery service reported an attempted drop-off at the location during a time window that, according to their records, had not yet begun. The timestamp on their confirmation system matched one of the offset clusters observed inside the shop at that moment. When cross-referenced later, the delivery had indeed been scheduled, but for a later time that aligned with the internal configuration already observed. The environment had presented a temporal state before it occurred externally. This was not prediction in the conventional sense. There was no evidence of information transfer or forecasting mechanism. Instead, the shop's internal time distribution periodically aligned with configurations that external systems would later reach through normal progression. The alignment was measurable, and it was repeatable. A more controlled verification was conducted using scheduled infrastructure activity. A maintenance window for a nearby communication relay was set several hours in advance. Observers documented the internal time distribution within the shop prior to the scheduled event. At a specific interval, a cluster of devices inside the shop aligned to a configuration that matched the exact timestamp range of the upcoming maintenance window. The alignment persisted briefly before dissolving into new offsets. When the scheduled time arrived externally, the same configuration appeared again inside the shop, but this time as part of the normal divergence cycle. The environment had occupied that temporal state twice, once before it occurred and once when it did. The implication altered operational posture. The anomaly was no longer considered an isolated inconsistency. It represented a localized condition in which temporal states could be accessed out of sequence, without altering the physical processes associated with those states. This distinction prevented immediate escalation to hazard classification. Systems outside the environment continued to function normally. No physical processes were disrupted. However, the integrity of time-dependent data within the environment could not be guaranteed, and its interaction with external systems introduced measurable inconsistencies. The shop was subsequently removed from all synchronized networks. Power supply was maintained through isolated infrastructure, and all data connections were severed. Access to the interior was restricted to controlled observation periods, during which no external timing systems were introduced. Over time, the internal behavior stabilized, not in the sense of returning to normal operation, but in forming a consistent pattern of divergence and convergence. The distribution of time offsets continued to cycle through configurations, some of which corresponded to external time states, others of which did not align with any recorded or scheduled interval. The mechanical chronometer at the center of the room remained a point of reference. Its behavior did not change in principle, but its adjustments became more precise. Each time the surrounding devices shifted, the chronometer repositioned itself within the distribution, maintaining a relative placement that could not be predicted from its previous state. It did not match any specific clock. It matched the structure of their divergence. Attempts to map the full sequence of internal configurations produced incomplete results. The number of possible arrangements exceeded the observation window, and certain configurations appeared only once before not repeating within the recorded period. This led to a final classification adjustment. The environment was not cycling through a closed set of temporal states. It was traversing a broader structure in which local time references could diverge, align, and reappear without fixed order. The shop remained physically unchanged. Its inventory continued to function. Customers passing along the street observed nothing unusual. Inside, every device continued to display a different time. The location has since been removed from commercial use. No public record indicates the reason. The building remains connected to the grid in a limited capacity, but its data output is excluded from synchronized systems. Periodic observation continues under restricted protocols. The condition has not resolved. At any given moment, the interior contains multiple valid time states, each anchored to a device that operates correctly within its own reference. No single time can be established for the space as a whole. And on several documented occasions, the configuration inside has matched intervals that external systems had not yet reached, only to align with them again later, as those intervals arrived through ordinary progression. The shop does not run fast or slow. It does not drift. It occupies time out of sequence.